Alright guys, welcome to today's class. Today we're going to continue where we left off last lesson and finish up these challenge problems, alright? In rectangle ABCD below, point E is on side CD such that CBE minus ADE is equal to AB minus CBE. What is the ratio of the area of the largest region to the area of the smallest region? I'll just have a try in this question and tell me answers through chat. Alright, let's get started with this question now. So what is the ratio between the largest area and the smallest area? Well, note that in order for this to happen, CBE minus AE is equal to AB minus CBE. Well, how can this happen? Well, so this is an extra area. So what if we draw a perpendicular line from E down to AB, an altitude? From here, we notice that we can say that ADE and say this point is ABCDEF. Let's say ADEF. We note that ADEF is a rectangle, since I'll make it so that AD is parallel to FE. And this is a rectangle, since all four angles are right angles. So these triangles are congruent. The ones I'm about to circle here. These two triangles, these two triangles that split this rectangle are equal. Similarly, for this one, this will be equal. Now you want to find the ratio of the area of the largest region to the area of the smallest region. Well, from here, you're just basically trying to see how can we make a ratio of this. Well, notice that, let's do size now. Notice that CB times EC divided by 2 is the area of CB. And similarly, ADE times DE divided by 2. And then finally, ABE is equal to AB times BD. I mean, AEB is basically AB times AD divided by 2. Why is it AD? Since FE in this case is equal to AD, and then there's AB. And it's also just half of the entire area, alright? So notice that AD is equal to BC. So we can plug all of these values in and get ED times EC minus AD times DE is equal to AB times BD, I mean AD divided by 2 times, I mean minus AD times EC divided by 2. Now we just making common denominator, and then from here it gets pretty obvious since ABE is AB times AD divided by 2, and ADE is ADE times AD divided by 2, which you can use from here get AB divided by DE. But then we have a ratio between we get this one, and we notice that EC minus from here you get EC minus DE is due to AB minus EC. Or solving is 2EC. Sorry, I'll have to switch because I don't have enough space. 2EC minus D is equal to AB. And then notice that since AB is equal to CD, which is also equal to DE plus EC, and then simplifying, you get EC is equal to 2DE. And then we can just plug it in and solve. We'll get 3 as our final answer. All right. So it's just finding the ratios between the lengths and then finding the answers. Now let's move on to 4.40. For Joel's birthday, Will has bought a 7 by 7 inch square birthday cake with a flat top. It is a chocolate cake with banana frosting on the top and on the sides. It turns out that 7 people will be present when the cake is cut, and each person will be quite envious if another person receives more cake or frosting. Find a way to divide the cake among 7 people so that each receives an equal amount of cake and frosting. I'll see if ever trying this question and tell us through chat. Let's get started with this question. So it actually is possible. So now, how would you do it? Well, I don't have the diagram, but there's actually one way. You can actually cut the thing into like somewhat like this, I believe. I know it's weird, but these will have seven same areas, equal amount of cake and frosting, and I believe the point is in the very center. And then you can have see that, and then you can keep on cutting. You can split all of these into 28 pieces, each of 4 pieces each. And then you can see that each will have an area of 7 fourths. And then you get the 7 for each one. I won't go too in detail, but the point is in the middle and just basically just splitting it into part pieces from starting from the point in the middle, going to each of the diagonals, and then you start splitting. Basically how it is. Alright, I'll skip this. Let's move on to 5. Similarity. Similar. What is similarity? It's basically how it's basically similar but different. You know, that's what the saying goes: similar but different. It's not if it's a congruent triangle, then is it also similar? Because it's basically a scale factor of that triangle, right? Scale factor by the ratio between the sides. For example, DC to GF ABCD is similar is basically has the same figure as EHGF. So they're this basically similar figures, and their similarity is by the ratio between the sides. How much bigger are they? Like for example, DC is like say twice one like half of GF. So GF is twice as CD. So this figure is like twice as big. Well, not in area though. Areas are different. But you get the idea. Alright? Let's move on to 5.1.1. Given that ABC is similar to YXZ, which of the following statements, ratios, must be true? Basically, corresponding ratios, right? See if these ratios are the same. Draw the diagram, right? I'll share by trying this question in semester chat. All right, let's get started with this question. So this is basically testing if the ratios are the same. All right. So if you test it correctly, then you should get A, B, and D working all properly, and C and E not working properly. Now, if ABC and ABB are similar, and AC is equal to 4 and AD is equal to 9, what is AB? So let's draw this diagram. Well, it's basically ABC, ADB. If AD is 9 and AC is equal to 4, notice that AB, we have two ABs over here. So we have AB to AC, we just pop out ratios, is equal to AD to AB. Simplifying and finding AB, you cross multiplying is pretty obvious, and then AB6. Alright, it's basically finding the ratios. Corresponding size always match up, alright? It's basically based on the figure representation, alright? Now, let's move on to 5.2, and one way to identify similarity between two triangles is angle. Two angles are the same, which is pretty obvious because if the figure is going to be the same, if the lengths are going to be different, then angles must be the same, right? You can't scale angles. It's not going to look the same, right? If we have another triangle that looks like this with double the lengths, obviously it wouldn't look the same, right? Especially applying this for these examples. Let's move on to the problem exercises. Let's find AC and BC and then find HJ in these examples. I'll let you guys try this question and tell me answer the chat. Well, let's get started with this question now. So, how do we do this? Well, we already have a hint. This is 7 and 21. These are corresponding segments, right? From here, since these are corresponding segments, you can get that the ratio is 3. So this will be 16 thirds, I believe. And this will be 4. Right? Not really that accurate. The shape figure is not really accurate, so don't let it fool you. Anyways, now we have FG to GH. We have these similar triangles. Now we want to find HJ. We clearly have a similarity. FGI is similar to FHI. Why? By angle because these are parallel lines. They are parallel lines. So the ratio is basically 13 to 4. And I'll let you do the calculation. It's basically 7 times 13 over 4 or 91 over 4 is HJ. Basically scaling it up by 13 divided by 4. Right? It's basically multiplying the ratio between and getting the answer. Anyways, we'll find ON and MN. Alright? In this diagram. Well, same exact thinking. Right? We have a right angle over here, right? Since this is 90 degrees. From here, we notice that this is 1.2. And we notice that this is basically this. Alright? But also, how do we know it's AA? Because this angle is 90 minus this angle, but this is also 90 minus this angle. So that's what you get. I'll show you. This angle is 90 minus this angle, which is also equal to this angle, which is 90, also 90 minus of this angle, right? So from here, you get LM to OM, the ratio is 4 thirds. So this will also be 4 thirds, so 4.8 divided by 3. I'll let you do the calculations. No, my bad. It's 6.4 divided by 3. Oh, my bad. Another my bad. It's actually 1.6. Hold up. Oh, my bad. I'm sorry. This will be 3/4, right? So this will be 3 halves. And finally this will be 0.9. Right? I'm so sorry. It's the ratio will be yes, I'm very okay. So basically the pro accidentally reverse the ratio. Make sure you don't please do not reverse the ratios. It's very important that you make sure the ratios are correct or else you're gonna find the wrong calculations. This case, now we want to find RS. Now, how do we find a similarity in this one? The similarity does not look quite obvious, but notice that we have a equal angle over here. There, we have a shared angle, which is P, which from here, you can also get that there's another angle that's equal. So from here, you can get PQR is equal to PST, and thereby find the ratio between this side and this side, which is 9 to 20. And we want to find RS. Well, we notice that 9 to 20 is equal to 8 to 9 plus RS. Alright? That's one way to go through it. And then solving, you can get RS is 79 divided by 99. I mean 79 divided by 9. Alright? And that's our answer. Let's move on to 5.2.2. If two isosceles triangles have vertex angles that have the same measures, then are the two triangles similar? Why or why not? I'll let you have a try on this question and tell us through chat. Let's get started with this question now. If two isosceles triangles have vertex angles that have the same measure, are the two triangles similar? Why or why not? No. I mean, yes, it can. My bad. Yes, it can. Why? Because since it's an isosceles triangle, it's not a normal triangle. One of you guys have misread that it's a normal triangle. Please read the question very, very carefully. It's important that you do, or else you'll lose a point for it. In the actual exam, you just lose that problem that was very, very simple to solve. And then voila, 1 point is gone. You might have missed the cutoff. Who knows? But anyways, if there's two isosceles triangles that have vertex angles that have the same measure, are the two triangles similar? Why or why not? Well, notice that these two sides are the same and the two base angles are the same. So this changes it entirely. Since the vertex angle is already known that they're the same, the two base angles must be the same because they're directly related to the vertex angle. If the vertex angle is the same, then the base angles are the same because the base angles are equal to each other. So let's say if it's x, then the base angles each are 180 minus x divided by 2, which works for both, and then both are equal, so that's the answer. Yes. Now I told you guys to have a try on 5.2.38. If I said so. Oh, I said 5.3.38. My bad. 5.2.38. So that WZ is parallel to XY. How does one go to approach this? WXYZ is a square, which pretty much comes obvious because you can draw this, you can take example for this transversal. This is a right angle, this is a right angle, transversal, the angles are the same. So by the transverse, by using this transversal, we can conclude that this is a parallel line indeed. Now you just have to prove AZ equals YB, which is pretty obvious because it's a midpoint of YZ, which basically comes into from congruency. It's basically congruency at this point. We have two angles and one side at AAS, and this follows AAS. And basically XB equals XA, same exact thing. It's just congruency. Find some stuff you need a triangle find, and then you find the answer, and you'll prove that it's congruent. And then you find XB equals XA, right? So that's it for today's class. I hope you guys have a wonderful day, and I'll see you next week. Bye.